Welcome. Today we are going to learn about sigma notation and the difference between a series versus a sequence. We've talked a lot about sequences in the past, last year in Secondary 1, and in this year, sequences of numbers is just a list of numbers, like ignore the plus symbols for a minute. A sequence of numbers would just be the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's a sequence of numbers. A series is when you add those numbers together. So these are series. It's a series, and it's called a finite series because we stop. So a series is a list of numbers that we're adding together. A finite series means it's just a set number of numbers. We will talk about infinite series in a little bit. We can abbreviate this. If I'm adding these integers from 1 to 10, I can abbreviate it by using this sigma notation. It's the capital Greek letter S, I believe, for summation. But it's a summation. And what it is we tell where we're going to start, and we always go by integers. So I'm starting with integer 1, and I'm going to up to 10. And then this is a formula that we're going to plug in these numbers. So in other words, I would plug in a 1 and take that number, which gives me 1. I would plug in a 2, and that just gives me 2. I would plug in a 3, and I would get a 3. And I would go all the way up until I get to 10. And then I sum those up, and I get a sum of 55. Okay, here's a different one. Okay, I'm taking the integers 1, 2, 4, 8, 16, 32, 64. And if you notice, each integer is twice the previous one. So I'm timesing by 2. Here I was, in a sense, adding 1. This is a linear sequence or series. This is a geometric series because I'm timesing by 2 to get to the next integer in the series. And so I can do that with a exponential equation. And I want you to notice here that I start with an n value of 0 and I go up to an n value of 6. That means there's actually 7 terms, 1 through 6 plus the 0. And the reason I started with 0 is what's 2 to the 0 power? Well, 2 to the 0 power is this leading 1. And then as I increase my n by an integer by 1, 2 to the 1 gives me 2. 2 squared gives me 4. 2 cubed gives me 8, and so forth. 2 to the 4th would be 16, and I go up until I reach 6, which is 64, and then I add those up, which is 127. So this is a geometric series. This was a linear series, an arithmetic series. You can actually have both, and but it's a very unique series. If you're adding the exact same number all the way across, so I have 1, 2, 3, 4, 5, 6, 7, 8 sevens that I'm adding together. So I'm adding just 7. It doesn't change. If you notice, there's nowhere to plug in an n. There's no n in this expression after the summation. So for the first n, I'm going to take 7. For the second n, I'm going to take 7. For the third n, I'm going to take 7. For the fourth n, I'm going to take 7. I'm going to do that 8 times, and then add them up and get 56. So this sequence is actually both an arithmetic series and a geometric series because I could be multiplying by 1. 7 times 1 is 7. 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 Or I could be adding 0. 7 plus 0 is 7. 7 plus 0 is 7. 7 plus 0 is 7. But then you add up all those, and you get 56. So it is possible, it doesn't happen very often, but you will see that in the IXL lessons where a sequence, or a series, is both arithmetic and geometric. But that's if you're adding just a constant. We can obviously be neither. So this sequence here is neither. In other words, to go from 1 to 4, 4 to 9, 9 to 16, 16 to 25, I'm not adding or multiplying. What I'm doing is I'm squaring. If I plug a 1 in, 1 squared gives me 1. If I plug a 2 in, 2 squared gives me 4. If I plug the next integer 3 in, 3 squared is 9. 4 squared is 16. And so on this is neither linear nor exponential, or neither arithmetic or geometric. but we can still express it in summation notation. So the first couple lessons I'm assigning, which is in pre-calculus, section W, 10 and 11. 10 is identifying whether a series is arithmetic or whether it's geometric, and also kind of writing the sequences out. So for instance, you might be, if I cover this up right here, you might be given this sequence, 12, 15, 18, 21, 24, 27, and 30, and you're asked to write the sequence in summation notation. Now in iExcel, it's going to be multiple choice, so you're going to have multiple options. But just remember that I'm going to look to see, how do I get from 12 to 15? Well, I added 3. How do I get from 15 to 18? I added 3. How do I go from 18 to 21? I add 3. So that means it has a common difference or a slope, a common common difference of 3. I started with 12 as long as 12 is my 0th term. That's why I started with 0. And then I just asked myself, how many terms are there? 1, 2, 3, 4, 5, 6, 7. 7 terms. So if I start with the 0th term, and then I only go up to 6, because that would be 7 total terms. And then I can just write this sequence out as this linear expression. To go from one term to the next is a linear expression, and I'm summing those terms. That's why I use the sum. Now, you're going to be asked to find the sum. We could take the time to add these all together, but what I want to emphasize is this. If I have a sequence and I find out that there's 1, 2, 3, 4, 5, 6, 7 terms, what I can do is I can actually add the first one to the last one. What's this first one and the last one add up to? It's 42, okay? And then what's this next one added to this one? Well, 15 and 27 is also 42. What's 18 and 24? That's also 42. And what's 21? It's half of 42. In other words, what I'm saying is I can add up the first to the last. So I add the first to the last, and then I'm going to either multiply by half the number of terms, because I'm basically cutting them in half, or I can divide that number and then multiply by the number of terms and again, I got to be careful. I'm going to put n, but the number of terms. So if there were 7 terms, I'd multiply by 7. Maybe I shouldn't use n, but the number of terms that there were, right? Divided by 2. So again, 30 plus 12 is 42. 42 divided by 2 is 21. 21, there was 7 terms, so I times that by 7, and I get 147 would be the sum of this sequence. We're going to do a few more in just a minute. But let me kind of make sure you understand what's going to go on. Introduction to sigma notation. Again, all I'm going to want you to do is at first just determine whether the series is arithmetic, geometric, and if it's infinite or series, or if it's infinite or finite. And the way you tell if it's infinite is if there's an infinity symbol in the sigma notation. So going from 1 to 85, there's a finite number. So you'll click finite and then hit submit. What? What did I click? Oh, you answered infinite. Why did I answer infinite? It was finite. I knew it was finite. We got that. I know, because usually when you hit finite, yeah, it brings up this. I was expecting it to bring up that. I should have dawned on me that I clicked the wrong button. If there's a number 46 up here, it's going to be finite. And then it just asks how many terms are in the series. So if I go from 1 to 46, there's obviously 46 terms. So again, it shouldn't be very difficult, this first one. Again, if I'm going from 1 to 33, there's definitely a finite, not an infinite, a finite. How many terms? Well, if I go from 1 to 33, there would be 33 terms. We're eventually going to get to one where it doesn't start. Yeah, see, this one starts with 0 and goes to 76. Since it still stops at 76, it's still finite. But don't type in 76. 1 to 76 would be 76, but we're also including 0. There's actually 77 terms in this series. And let's skip ahead a little bit here, because I want to hopefully do little harder ones here. Again, this is a finite series because ends at 61. How many terms? Well, since it starts with 0, 1 to 61, 61 plus the 0 is 62. I know they have some in here where it actually starts in the negatives. Let's jump ahead again. Yeah, like this one. This one actually starts at 5, the 5th integer, and goes up to 28. Since it still stops at 28, it's still a finite series, but we got to think, all right, to go from 5 to 28, I include 5, so all I do is I go 28 minus 1 less than this, or 4. What's 28 minus 4? There's 24 terms. Because if you did 28 minus 5, it's like you're not including that 5th number, or that 5, and then you'd be 1 short. You actually have to do 28 minus 1 smaller than that number there. So 28 minus 4 is 24. Here, we're starting at negative 3. So again, we're ending at 12, so it's definitely finite. Okay, how many terms in the series? Well, don't do accidentally 12 minus a minus 3 and get 15, because from 1 to 12 is 12. From negative 1 to negative 3 is 3 more. 12 and 3 more is 15, but I didn't include 0. 0 is one of the terms. You've got to always include 0. So I'd actually do 12 minus a minus 3 and add 1 more, or 12 minus a minus 4, 12 plus 4. There's actually 16 terms. Just got to make sure you include the 0th term as well. Okay, so I'm going to skip ahead again. Again, here, this is write the series using sigma notation. With sigma notation, again, the first thing I'm going to do is try to find out if it's arithmetic or geometric. Now, to get from 5 to 10, I add 5. To get from 10 to 20, I add 10. To get from 20 to 40, I add 20. So it's not arithmetic. I'm adding the same. But what if I double? 5 times 2 is 10. 10 times 2 is 20. 20 times 2 is 40. 40 times 2 is 80. So in other words, I'm multiplying by 2. So if you'll notice, all of these have that 2 with an exponent, because it's geometric series. Now I just got to decide, okay, which one of these works? First of all, how many terms are there? 1, 2, 3, 4, 5 terms. So I better have 5 terms. 1 to 6 is too many. 1 to 6 is too many. That's 6 terms. I want 5 terms. So it's either one of these bottom 2. Then I just start, okay, if I stick in a 1, do I get 5? I don't. I would get 10 in this one if I plugged a 1 here. 2 to the 1 power is 2. 2 times 5 is 10. So plugging in a 1 doesn't get me the 5. It got me the 10. But if I plug a 1 in here, 1 minus 1 is 0. 2 to the 0 power is 1 times 5. It's this one. This one starts with 5. And if I plugged in a 1, 2, 3, 4, 5, or the 5, I guess, I should have looked here. If I plug in a 5, it's 2 to the 4th. 5 minus 1 is 4. 2 to the 4th is 16. 16 times 5 is 80. So it works, right? So here, this one obviously is probably going to be linear because I have a constant rate of change of 2 or 6. This one is a constant rate of change of 5 halves because I don't see any exponents on my variables. So again, how do I go from 4 to 10? I add 6. 10 to 16, I add 6. 16 to 22, I add 6. So my rate of change is 6. That eliminates all 3 of the others. But we still could make sure it works by plugging in a 0. 6 times 0 is 0 plus 4 gives me the 4th term. If I plug in a 1, 6 times 1 is 6 plus 4 gives me 10. So it's a linear one. So hopefully you'll be able to work through these. If you do have questions on these, please do ask. But I want to get to the next section to make sure you understand what I want you to do here on 11, where it says find the sum of arithmetic sequences. When you find the sum, what I want to emphasize is if you have a sum, I mean, just think of doing 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9. Just stop at 9. What is the first one added to the last one? What's 1 plus 9? 1 plus 9 is 10. What's the second to first one, this second one, and the second to last one? What's 2 plus 8? Oh, 2 plus 8 is 10. What's 3 plus 7? Oh, 3 plus 7 is 10. What's 4 plus 6? Oh, 4 plus 6 is 10. In other words, as long as it's an arithmetic series, the first, if you pair them up, first to last, second to first to second to last, you get the same number. If you'll notice, since there was an odd amount of numbers here, I ended up with just a single 5, which, by the way, is half of that 10. So what you can do is you always, again, if you remember up here, you add the first to the last, you divide by 2 at some point, and then you times by how many terms there are. So for this one, on this worksheet on the Excel here, the first thing I'm going to do is I'm going to realize how many terms are there. There are 12 terms, okay, in this sequence on the Excel over here. Now, if I plug in a 1, what's my first term? 6 times 1 is 6, plus 4 is 10. My first term is 10. I'm going to add that to my last term. Well, my last term is when I plug in a 12. So I plug a 12, 6 times 12 is going to be 72. 72 plus 4 is 76. So I'm going to add that first plus the last, and then I'm going to either divide it by 2 or multiply by half the number of terms there are. So times by 12. So I find it easier to go, okay, 10 plus 76 is 86. Half of 12 is 6, so I'm going to multiply by 6. That's 36. 6 times 8 is 48, 49, 50, 51. So the sum of that series would be 516. Now, if you're very unsure, you could write down all 12 terms and add them up manually, but we would get the same sum. So again, as an example, and then we'll call it good because we're about at 17 minutes here. Again, I have how many terms here? Well, I have 17 terms, okay? So what I'm going to do is multiply by 17, okay? Now that's not an even number, so I might not divide the 17 by 2. I might add the two sum, because remember, I'm going to take the first term and add it to the second term. Not the second, the last term, sorry. Let's find the first term in this sequence. So if I plug a 1 in, what's the first term? 6 times 1 is 6. 6 minus 3 is 3. So my first term is 3. Then I'm going to add it to the last term. Now my last term is the 17th term. So if I plug a 17 in here, and you might have to do this off to the side, 17 times 6 is what? 42, 6, 102. Minus the 3, don't forget to minus the 3. Minus the 3 is 99, so I'm going to add 99. So I have 33 plus 99. This was the first term, this was the last term. Well, 33 plus 99 is going to be 102, which I find a lot easier to divide by 2. So 102 divided by 2 is going to be 51. 51 times 17. In fact, maybe I'll even really cheat here, grab my calculator and go 51 times 17 and get 867. So I come over here and type in 867 and I get my sum. So all of these should be arithmetic in this lesson in number 10. So again, you just need to find the first term by plugging in that first one. Now be careful, make sure it's a 1. Don't just assume it's a 1, it might not be. As you get higher, they might have different base numbers here. Okay, come on. I'm hoping that, yeah, like this one here, see it starts with a 6. So don't worry that it starts with the 6. You're still going to find the first term, which is when you plug in a 6. 5 times 6 is 30. 30 plus 2 is 32. So I have 32 plus, what will the last term be when I plug in a 60? Well, 5 times 60 is 300 plus the 2, so I'm adding 302. I'm going to multiply by how many terms there are. Now be careful, remember how we calculate the number of terms. It's not 60 minus 6, or you'll be 1 short. It's 60 minus 5. 60 minus 5 means there's 55 terms, and then we divide by 2 at some point. So what I'm going to do is add those two together. That's going to give me my 334. I'm going to times that by 55 and divide by 2. Well, 334 divided by 2 is going to be 167 times 55. And again, I'm going to grab my calculator. And maybe if you wanted to, you could even come up here and do it right here. You could do 32 plus 302 to make sure you, not 3.2, 32 plus 302 gives you that 334 times 55. So I'm doing the multiplication first, divided by 2. gives me a sum of 9,000. Oh, you can't see that calculator. I'm sorry. I was holding the calculator all weird. So I added, then I times by 55, then I divided by 2, and I got this sum of 9,185. 9,185. Again, if you have any questions, please do contact me, and I will help you as much